What's up, everyone? This is going to be a bit of a different episode than what my other episodes have kind of been. I either have the Game Engine series or the Let's Learn Zig series. This is kind of relating to Let's Learn Zig, but I want to do something a little bit bigger in scope and more interesting than rather just learning functions or variables, things like that. This video is about creating a CRUD HTTP server in Zig with no dependencies, nothing. It's just show every line of code. It's like just over 200 lines of code that we write. Every single line is written in the video. So yeah, it's just a basic CRUD app. It's just you create a node, you can get a node, you can list your nodes, you can update a node and delete a node. That's it. It's all in memory. And yeah, so we're not connecting a database right now because I just want to show the more server part and how to respond with JSON and how to receive a request and things like that. But please comment down below if you want me to almost turn this into a mini series that we continue to extend. I'm thinking if people really like this, I'm going to do another episode where we take the code we wrote today and then update it from being in memory and add on a database layer. So then it's a CRUD app that's actually a little bit more useful because it's connected to a database, but I'm not going to do that if you guys aren't interested. So please, if you like the video, comment down below and tell me you're interested in that, and I'll make the video. I think this is going to be a valuable resource now that Zig 0.16 is out. This is using Zig 0.16, the new IO and all that. Yeah, please leave a comment if you enjoy or what you want to see. And there's quite a bit of code to write, so let's jump into it. The first thing we're going to do is just explore what this looks like. It's a very simple Zig project. So one thing I have done is you can go check out the repo to get this, but just a very simple makefile so we can test our commands easily. So like list, post, get, update, delete. We're going to be implementing all that today. So this will just help us test it really easily. And then it's a very simple build.zig file where all it does is build and runs tests. This is exactly what you get from Zig init, but I just took out the import module and then nothing here. And we have an empty main. So again, there's no code here. We're going to start from scratch and write every line. So let's get into it. The very first thing we're going to do is just grab a couple imports. So we want IO from std.io and net from IO. Those will be the two imports we grab. And now let's jump into it. So the IO we're going to be using is init.io. This is a nice part of Zig 0.16. And the first thing we can do is create an address that we're going to create from our networking. So IP address, and then we'll just parse. So let's just do localhost 7.0.0.1, and we'll do port 8080, which is a pretty standard port. So all this does is create an IP address for us. The next thing we do is create our actual server. So server equals try address.listen. It'll take that IO, and reuse address is going to be set to true. And then we'll defer server.dnet with IO. Let's just make sure this is easier for us to read. And yeah, so what we did, we created an IP address, and now we're listening on that IP address. So we've created a server on that. We aren't actually handling connections yet. Okay, and let's create a debug log. So std debug print listening on hp //127.0.0.1:8080. Okay, so now let's actually create our server. And what I mean by that is our while loop. So remember, servers run continuously, no matter what. So that's what this loop is going to be. And the first thing we'll do is accept a connection. So we'll grab a stream from our server, accept IO, and then we'll handle the connection. So this is not meant to be like the highest performance kind of HTTP server that you're going to create. I'm just showing you guys how to use a standard library to start listening and accepting HTTP requests. So handle connection is what we're going to write. And we don't actually have this app yet either. So there's a few things here that we will need, but yeah, so we'll keep going and then we will come back to this once we have everything, but we'll just start writing handle connection next. So handle connection, we'll take obviously the IO, stream, net.stream, and then app, which we haven't created yet, but we will get there very soon. And then defer stream.close with the IO, because that can happen. So now the next thing we'll do is actually create our readers and writers from the server. Our read buffer is just going to be a simple buffer. 4096 of U8. So just a byte of stream of bytes, undefined. We'll do the same thing, but we'll do a write buffer. And then we'll create a reader. So connection reader equals stream dot reader IO and grab the read buffer. Instead of reader, we'll replace read with write. So connection writer and write buffer. Let's see, one little mistake there, and stream writer. There we go. And then I guess this looks a little funky. Okay. I'm gonna try to keep everything on the screen, but we have our read, write buffers, and then we're using those to create our actual stream readers and writers. The last thing we'll do is, because if we go back here, what we actually did up here is we're just listening on an address. So it's not an actual HTTP server yet, but what we're going to do is create that actual HTTP server from these readers and writers, because what we've actually done is just opened up like a TCP stream for us. So we'll create the actual HTTP server itself, std.http.Server, and in it, and it'll take a connection reader dot interface and a connection writer dot interface. And now we can do the actual receiving a request, right? While server.reader.state equals ready. So while we're in a ready state, we'll actually get a request. So server receive head, and we'll obviously catch any error that happens there and then switch on that just so we have better error handling. And if error.hp connection closing, we'll just immediately return because that means our connection's closed. Else we'll just print it out. Debug print failed to read request and pass in the error and then return after that. So we're continuing on the path of now just writing as we go. So route. So now we actually have to route the request. So we receive the request and it's the right one, or like it's a valid request, but how do we know where we want to go? Is it a post? Is it a get? So all the things like that, we have to manually implement a router ourselves, and that's okay. So we'll do the request in app and then catch any error that happens here, and then also print. And failed to serve S and T. There we go. And request.head.target, and then the error. Hopefully that's making sense so far, but we're gonna write route next, and then it's just if there's an error, we print it. Okay, and before we write the route function, we're just gonna write in a simple helper, spawn JSON, so request chp server dot request. It's gonna take a status of an HTTP status, and then the body itself. So this will just actually do the kind of respond JSON, send back JSON with a response. So request respond the body dot status equals status and dot extra headers. In this case, it's just making it easier for us so we don't have to write it every time. Name equals content type, and value will equal application slash JSON. Should be self-explanatory. This is just saying send these bytes with the status responding to this request. So now let's just get back to route. So function route can take a request, of course. cd hp server request, and then it'll take the app with an app, which we'll write after this function. We'll write our app. So const method equals request dot head dot method and const path equals request dot head dot target. Okay, so now we have to do some actual checking. So if the path equals slash notes, then we will return a switch on the method to actually do stuff. So we will fill this in just write to do, fill in, and then we're gonna do something very similar here. But now instead of directly equal, we're gonna do a starts with. So if it starts with /notes, then we know there's gonna be more. So like there's gonna be go over to makefile, that's something like /notes. This is directly an equal, right? But over here, it's starts with notes, but then has an ID of 1. So that's what this is going to say. So we'll have to grab that ID, text equals path /notes /.len, and then everything after it, right? So you go from however long this is up until the end, and then const ID, we'll actually make sure it's a valid ID. So we have to parse int u32 ID text base 10 catch, and then return. So this is where we'll have that respond JSON function to the request. It's going to be not bad gateway, but bad request. And this is kind of probably the worst part, is just writing manual JSON here. So we will have this, and then escape back quote, error, and it's going to be invalid note ID. And that should be it. So now we have a valid ID, and then we will do the same return switch method, which we'll fill in right there. And then otherwise, if we're at the end, let's just grab this respond JSON and say not found, right? Give back a 404 and say error not found. One thing we can fill in is actually just the else case. So we'll probably grab one of these, respond JSON, and then say method not allowed, and then do method not allowed. And then we'll do the exact same thing up here. And we'll fill in the rest of methods very shortly. Okay, and as promised, we're going to create the app, and then we will try to actually run our program for the first time. And it's not going to do anything because we aren't actually handling any methods, but it should start returning with method not found. Probably should have started with this, but what is this app going to do is it's just going to take notes. So what is a note? It's going to be a struct with a simple ID, which is u32, and some text. This is going to be an in-memory kind of database, so we're not doing anything fancy. The goal of this episode is just HTTP requests and a basic CRUD. So let's create the app. App is a struct. It's going to take an allocator. It's going to take notes, of course. This should be ArrayList of note. It's going to always default to empty. And then next ID is just going to track its own ID. Okay, and then we'll just have some simple functions like dinit. And then for app notes items. For every note, we will just free it because we're going to be allocating it, the text itself. Then app.notes.dinit allocator. And now let's create our helper function. So this is, again, essentially our database, right? So it's all in memory, but it's just going to be like, how do we create something, find something, and delete something? So create note based off some text. And then create the note. Note. And then .id equals app.nextId. And .text equals try app allocator dupe. So it takes ownership. And then app.nextId, let's just increment that by 1. And try app.notes.append, app.allocator, and the note itself. And we'll also return the note from there. Nice. So next will be find note. And we'll be finding it based off the ID. And it's going to optionally return a note because it might not be found. So app.notes.items, take a note. If note.id equals ID, then we return that note. Otherwise, we'll return null. So last one here will be delete note an app, and again, same with ID, and just be bool if it deleted or not. So for app.notes.items, let's take the index. So note index if note.id equals ID, app allocator free note.text, and then do an order remove notes.ordered remove. So then it like kind of shifts everything back and return true. Otherwise, return false. Nice. So that was all we had for there. The last thing here is going to be actually creating our app. So if our app, give me an instance of an app, then all it's going to take is an allocator, which is init.gpa. Again, a very nice thing about the new process.init is just we have access to this very easily. And then we'll de-init it. So now we are going to be passing app everywhere. So we don't actually use app yet here, but just so we can actually try and compile our program. And same with ID. We don't actually use it, but let's see if we made any mistakes. There we go. So we're listening on localhost. And now if you run that kind of make list, we see a method not allowed. So you already have a server up and running. Let's just take a second, kind of think about that. We have a server that's running. It's able to handle requests, make post, or get, update. So obviously we're not actually handling these yet, but see, we're getting this method not allowed. So it's going all the way through here, and then it's either responding with the method not allowed here or down here. And now let's just keep going and fill in these methods. So I'll do is I'll undo those last couple changes, so because we'll need access to those again. And now let's fill it in. So we'll be writing a lot of methods here, but let's say .get will be list notes, which again we will write, and then .post will be create note, request an app. There we go. And then down here, this will be our get, put, and delete. So this will be get single note. And then we'll actually use the ID now. So put, delete, this will be update note and delete note. So now we have a bunch of functions to go write. Okay, so the first thing, just like we have respond JSON, I'm going to write just 2 more helper functions. That's going to make our lives a little bit easier. The first one will be append note JSON. So the body will be a pointer to an array list of U8s. Then we'll have an allocator, and then the note itself. And then it can return error or void. And what will this look like? We'll try body.print allocator. So we'll have ID, and then the D there, text, colon, one more, close it out, and then note.id. So that'll do the format properly and format into actual JSON, and try append JSON string, which this is the other helper we're about to write, allocator and note.text. Okay, so we'll try and end it with a body append slice, pass in the allocator, and then you have to close that, curly brace, and close again. There we go. So now the last helper will be that append JSON string. So obviously it's not as easy working with JSON in Zig, right? So that's okay. That's why you kind of create helper functions like this. You can use libraries, anything like that to help. But I'm trying to do everything by hand here just to show it can be done. So const u8 will also be the same void. Okay, so now for text, and again, I'm not trying to do the most efficient thing here, just getting something working. Byte. So if this is like dealing with escape cases. Allocator. So kind of have to double it, and then single quote, body append slice allocator, then just a single one there with an extra quote. So just doing kind of proper escaping. And the new line will be double backslash, get that back, double backslash, and then same with R, and then same with T. And then the else case will just be appending the byte itself. So again, this is just proper escaping. Definitely better ways to do it, but this is safe, it works. We're going to stick with it. Okay, let's start filling in our actual functions. So we'll have list notes, std.http.Server, request, and then app, which is pointer to an app, and then pointer void. So list notes, let's do get note, create note, and then an update note. Just want to also take that ID, U32, update note, and delete note. And the get note also needs that U32. Let's do the list notes. So we're going to be, first we need the body. So this is what we're going to construct to send back. U8, and it's going to start empty. And defer body dnit app.allocator. Okay, so try body append app.allocator start with an array. Because remember, we're listing notes here, so a JSON array starts with this, and then we'll also have the closing at the end. Just not forget about it. And for app notes items 0 ... we'll have the note and the index, and then if index equals greater than 0, we'll want to append the comma. So body append slice app allocator comma. Otherwise, we will just do try append note JSON. So we'll pass in the body. This is again the helper we already wrote, a note. So this is just an easy way to serialize a note as JSON. And then once we do that, we'll do our respond JSON. So it's going to respond okay and body.items. And that's it. So this will respond with anything that's in memory that's been created. It's going to respond with that list. So now let's go over to get notes. So how will we get a note? Well, we'll do app.find note on the ID, or else we'll have to respond JSON, the request, not found. We'll have to do our custom JSON here. So error note not found. There we go. And then otherwise, I'm going to take these couple lines because it's helpful and try append note JSON, the body app.allocator, and then the note we grabbed. And then try respond JSON request dot okay body dot items. So let's actually just go down to a simple one. And it's going to be if not app dot delete note ID will return not found, otherwise respond JSON. The request, it was okay. Deleted, true. There we go. And if that's not as clear for people, do that. And yeah, do the same thing up here. Make it easier for everyone to read. Okay, so we do need one more helper function. It's going to be read body, which because create and update, those are the ones where we're actually passing a body into the payload. So we will need to be able to read it. This function, read body. So we're going to read our request body, of course. HTTP. So we'll take a request and an allocator. and then it'll return the body it reads, right? Const length equals request.head.content length, or else return allocator. So it's going to be just an empty string that we will have to free, but it's not really going to do anything. That just helps. So if length is greater than 1024, we're just going to say it's too big for us, which we won't really run into, but it's good to have validations. Too large. Otherwise, for our body buffer, 1024 u8 equals undefined, and var reader equals try request dot reader expect continue, and then do the body buffer, and then return reader dot read allocator, and it cast length. Okay, so this will read the like it'll just read the buffer into a string, really, because read alloc is just going to allocate it. And that's why we did this allocator.dupe, because the consumer of this will have to use free. Like we'll have to free whatever is returned. And if we just did an empty string, you can't free that. Okay, so let's head over into create note. So const text equals try read body request app.allocator and defer. So this is exactly app.allocator.free the text, how it needs to be freed. So if text.length equals 0, let's grab one of these just to make it a little easier to work with. And it also says not found, note found. Let me fix that first. So note found, and then right here as well. Oh, I might have done that in a few places. Okay, this is the one I want right now. Okay, so it will have a bad request, and it'll be request body is empty. That's what we don't want. So now we will actually try and create the note. Create note with the text. And then now we'll have a response body that we make. ArrayList u8 equals dot empty. And then again, we've done this part. Body.dinit app.allocator. And try append note JSON. Body app.allocator, the note itself. And then try respond JSON with that body. Dot created and body dot items. Okay, we are almost there. We're gonna start copying things that we've already done. So like get note. So the first thing we do when we go and update, we want to make sure we actually have the note, right? And if not, then we want to read the body. So we will now read the body. And same thing if text is 0, text.length, we don't actually want to continue. So now we're updating. So what's the first thing we have to do? Well, we have to free the old text. So app.allocator.free note.text. This is the old one. So we want to make sure we don't have any memory leaks. And now we can do note.text equals try app allocator dupe wait text. So then it's going to take ownership. And now we can respond with the body. So we'll probably want something pretty similar to this. And actually, let's create the body, of course. So we'll create the body, app.allocator note. This time it's a pointer, and then respond JSON. In this case, it's going to be okay. And then we'll respond the same. Okay, and with that said, I think we have implemented everything. There might be an error somewhere, but we can cancel that and try and run it. Okay, let's debug this. Expected that, so let's go over to 273. This probably needs to be append byte maybe, or what was the function call? Oh, just append. Just append. Okay, let's try that one. Okay, we're listening. Let's see what happens now. So make list. Okay, we curled /notes and we returned an empty array. Let's just do get not found, and then we'd expect the same for update, delete. There we go, not found. So make post. Okay, it created one. So let's first do the list. We see it's in there. Make get. It's gonna get that first ID. Let's do a make post again. There we go. And then make update. So we updated one from, we had let's learn or learn zig to now learn zig and build APIs. So if we do a make get, it's learn zig and make APIs, same with list. Perfect. And the last one we have to test is delete. So successfully deleted. If we try again, it's going to say not found. And if we do list, we can see the one with ID 2 is gone, or ID 1 is gone. So everything works, and you have now successfully written a CRUD API server in Zig. I hope you enjoyed the video. I think this was a very fun one, very cool. I don't think there's a lot of resources like this out there on Zig, especially in video form. So let me know if you enjoyed writing every single line by scratch. It's a little harder with Zig because it's very verbose, so you're writing a lot of code, but again, please let me know if you enjoyed it. If you want me to extend this and turn this to a mini series, I will do that. If you have other ideas, you might not want a database connection, you might want to do something else with this app. Please leave any ideas down in the description. I want to incorporate feedback and hear from you guys. And if you want to chat, there's also a Discord link down in the description. Come say hi. It's a great way to chat. It's always fun talking to you guys. But yeah, that's all I have. So thank you so much for watching the video and have a great day.